So hello and welcome on this video on partial differentiation. So first of all we will discuss when we apply the concept of partial differentiation. So the concept of partial differentiation is applicable. It is applicable on function of more than one variable. Okay, means as long as we are dealing with a function of one variable, we do not use this concept. This is applicable only when we are having a function of more than one variable. Now what do we mean by this? So let us take some example, like if you are dealing with a square, and if you have to calculate the area of a square, so that will be a square, where this a is the side of the square. So here this is the case of a function of one variable. Okay, means this area of a square depends only on one variable, which is the side of the square. Now on the other hand, if you have to discuss the area of a rectangle, then this is L into B, where L is the length, B is the breadth of the rectangle. So this is the case of two variable function. So the concept of partial differentiation is applicable in this type of scenario, right? If you ask some more example, then yes, we can discuss if you have to calculate the volume of a cuboid, then that will be L into B into H. So here this volume of the cuboid depends on three variables. One is L, second one is B, and third one is H. Means if you change any of these variables, then we have a corresponding change in the volume of the cuboid. So again, if you look at this function, means the volume of a cuboid, so this is a three variable function. So we have the concept of partial differentiation whenever we are having a function of two variables, as we are having here, or a function of three variables, or maybe more than three variables. Means if you have a function of n variables, then we can apply this concept of partial differentiation. Okay, so this is the first condition where we can apply the concept of partial differentiation. Now how do we perform this partial differentiation? So let us recall our first principle, and let us consider a function y, which is a function of only one variable fx. Then if we have to find out the differentiation or differential coefficient of y with respect to x, so the idea was that we have to evaluate this limit. Okay, this limit is the differential coefficient of y with respect to x. So this is the case of one variable function. That's why we are differentiating this y ordinary. We are finding the ordinary derivative of y with respect to x. Now on the other hand, if you are having a function z which is the function of two variables x and y, so again as we discussed here, this is the case. Now we can apply the concept of partial differentiation. So here we can, because this z depends on two variables x and y, so we can differentiate this z with respect to x or with respect to y. So the first change is in the notation, means now you, in place of d, we are using del. So this is how we differentiate between the ordinary derivative and the partial derivative. Now how do we find out this? So we again have the same concept here, but because we are having two variables, so now here we are finding the derivative of z with respect to x. So we are just giving this increment only in x, and we keep our y as it is, and this limit will give us the partial derivative of z with respect to x. And similarly, if you have to find the partial derivative of z with respect to y, so this will be limit k tends to 0 f of x. Now because we are differentiating with respect to y, so we are giving this increment only in y and keeping our x fixed. So the first limit gives us the partial derivative of z with respect to x, while the second limit gives us the partial derivative of z with respect to y. Now from here it will be good if we mark certain remarks here. So if you look at this, so if we are performing the partial differentiation with respect to x, so we are giving only we are giving the increment only in x and keeping y as constant. So our first remark is to find the partial derivatives of or you can say that partial derivative with respect to x, we keep or we consider y as constant. Okay, so when you are performing the partial differentiation with respect to x, we consider this y as constant, and same if we are finding to find del z over del y, we consider x as constant. So this is the case of two variables. We can have the same concept for a function of more than two variables, means 3, 4 or maybe n. So the idea is that we will consider only one variable with respect to which we are performing the differentiation, and we consider all the other variables as constant. So what does it mean? So let us have certain example here. So let we are given a function z which is given as x square plus y square. I am taking a very simple example here. So if you have to find out del z over del x, so this means we are if you put the expression of z, so that will be x square plus y square. So this is del over del x of x square plus del over del x of y square. So now because we are performing the differentiation with respect to x, so we consider this y as constant, so the derivative of this is 0, and the differentiation of x square with respect to x is 2x. So this simply comes out as 2x. Now if you have to find out the derivative of z with respect to y, so now we are performing the derivative of z with respect to y. So now if you put this expression here, so this will be del over del y of x square plus del over del y of y square. So from here, because we are performing the differentiation with respect to y, so this comes out as 0, and this derivative of y square with respect to y is 2y. So this is coming out as 2y. So this is how we can find out the partial differentiation. Okay, we have to consider all the other variables as constant except the variable with respect to which we are performing the differentiation. Now if let us take one more example here. So let we are having this function, another example here, and this is the case of implicit function. So we are having that z is a function of the variables x and y again, but this time what we are having, or what we are given that they are connected like this. All the three variables, means the independent as well as the dependent variables, are connected like this. Okay, so this is the case of implicit function, because z is the function of x and y, but it appears itself in this expression. So now what we have to do, we have to find out the partial derivative of z with respect to x and partial derivative of z with respect to y. So let us consider this, our equation number 1. So differentiating partially one with respect to x. So this gives means what we are doing, we are performing this differentiation with respect to x. So this is del over del x of x cube plus y cube plus z cube plus 6xyz, and on the right hand side we are having 1. So we have to perform the differentiation of 1 with respect to x. So here you will have del over del x of x cube plus del over del x of y cube plus del over del x of z cube plus del over del x of 6xyz, and on the right hand side because we are differentiating with respect to x, so this comes out as 0 because 1 is constant. Okay, now here what you are having, 3x square. Now this will be 0 because you are performing this differentiation with respect to x, so this will be 0, while this is not 0. Why? Because this z is the function of x and y. Okay, so you cannot consider this 0. What you have to do, you have to differentiate this z cube with respect to x. So first we have to perform this differentiation with due to this exponent, which is 3. So this comes out as 3z square. Now because z is the function of x, which is given here, so we have del z over del x. Okay, now next, if you look at this, so in this bracket, this 6 and this y, they are constant. okay, because y is constant, because we are performing this differentiation with respect to x. So what we will do, we consider this 6y as, or we can take it out because this is constant. And now if you perform this differentiation, okay, so del over del x of xz, and on the right hand side we are having this 0. So now what we are having here, this is 3x square plus 3z square del z over del x plus 6y. Now here we have to apply the product rule. So we have to differentiate the first function, which is x, and keep the second function, which is z, as it is. Now the next term will be x times del over del x of z is equals to 0. So this comes out as 3x square plus 3z square del z over del x plus 6y. Now the derivative of x with respect to x is 1. So here we are having only z plus this x is as it is. Now the derivative of z is del z over del x, because we are not having any specific expression of z, so we give the notation as del z over del x. So from here we are having 3x square plus 3z square del z over del x plus 6yz plus 6xy del z over del x is equals to 0. Now we can make it more simpler by combining the like terms. So this will give us 3x square plus 6yz, and here we will take this del z over del x as common from these two terms, okay, from these two terms, and we are having 3z square plus 6xy is equals to 0. So from here you will obtain del z over del x 3z square plus 6xy, and we can transfer this bracket towards the right hand side. So this gives us 3x square plus 6yz. So from here you will obtain this del z over del x as minus, and you can take this 3 as common, so this is x square plus yz, and in the denominator again you can take this 3 common from this bracket also, so we are having z square plus xy, sorry, this will be 2yz and this will be 2xy. So this is coming out minus x square plus yz upon z square plus 2xy. Again I forgot this 2 here. So this is the partial derivative of z with respect to x. So this is the complete steps involved in this derivative, okay, so that you can have a clear understanding how we are obtaining this partial derivative. Now next we have to differentiate one with respect to y partially, okay. So now we are differentiating this equation 1 which is given to us with respect to y, and so what we are having del over del y of x cube plus y cube plus z cube plus 6xy z, and on the right hand side we are having 1. So this gives us del over del y of x cube plus del over del y of y cube plus del over del y of z cube plus del over del y of 6xyz, and on the right hand side we are having 0 again, because this one is constant, so the derivative of a constant is 0. Now again here we are having 0 because you are performing the differentiation with respect to y, and this is the function of x alone. Okay, so this is constant, and this will be 3y square, and again this z is the function of x and y, so we cannot consider this constant because z is the function of y, so we need to differentiate this. So this will be 3z square, and we are having del z over del y, and again if you take this 6x outside, because why? Because you are performing the differentiation with respect to y, and this x is constant and 6 is also constant, so we are having del over del y of yz is equals to 0. So from here you will get 3y square plus 3z square del z over del y plus 6x, and again we have to use the product rule here as we did in the previous part. So this is simply comes out when you differentiate y, which is your first function, so you will get 1, and we keep our second function z as it is, plus now first function is y and we have to differentiate z with respect to y, so this will be del z over del y is equals to 0. So from here we will get 3y square plus 3z square del z over del y plus 6xz plus 6xy del z over del y is equals to 0. Now again we combine the like terms, so this will be 3y square plus 6xz plus 3z square plus 6xy, and we are having del z over del y is equals to 0. So from here you will obtain del z over del y as minus, and you can take this 3 outside, so this is y square plus 2xz divided by, again you can take this 3 outside, we are having z square plus 2xy. Okay, so this will be minus y square plus 2xz divided by z square plus 2xy. So this is what we are having as our del z over del y. So this is our partial differentiation of z with respect to y. So this is how we can perform our partial differentiation. Now let us take one more example here. So in this example, again we are given a function z and this is defined as e to the power ax plus by multiplied by f ax minus bi, where this f is not given explicitly, means this is the function of ax minus by. Now we have to show that b times del z over del x plus a times del z over del y should be 2 times a b z. Okay, where a b are given here and z is the function. So let us begin with the solution here. So let us begin with the del z over del x, and this del z over del x means this, we are using this expression. Okay, so del z over del x, now first we need to apply the product rule, because we are having a function here e to the power ax plus by, and we are having another function, okay, which is f of ax minus by. So we have to apply the product rule. So this will be del over del x of e to the power ax plus by multiplied by f of ax minus by. So when you apply the product rule, so this will be del over del x of e to the power ax plus by, and we have this f of ax minus by as it is, plus we have this e to the power ax plus by. Now the derivative of second function, which is f of ax minus by. So this is when you differentiate this. So first we need to differentiate this due to this exponential. So this is e to the power ax plus by as it is. Now next we have to differentiate this, because this is the case of function of function, means this is the function which is having exponential function. Now in the exponent we are having another function. So we are having this e to the power ax plus by. Now when we differentiate this ax plus by with respect to x, so this is coming out as a, okay, means the derivative of this ax plus by. Now we are having this f of ax minus by as it is, plus e to the power ax plus by. Now the derivative of this, so because we are not having any explicit expression of this f, so what we do, we just represent this by f prime, means the derivative of f. Now again this is the case of function of function. So now you need to differentiate this ax minus by with respect to x. So this is coming out as a. So we are having this is as del z over del x. Now what we have to do, we have to multiply this by b, because we have to show that b times del z over del x plus a times del z over del y is 2abz. So now we multiply, so this gives b times del z over del x as a b e to the power ax plus by f times ax minus by plus a b e to the power ax plus by f prime of ax minus by. So this is b times del z over del x. Now next what we have to find out, we have to find out del z over del y, which is del over del y of e to the power ax plus by f of ax minus by. So here we have to apply the partial derivative. So this first we have to differentiate this first function, which is e to the power ax plus by with respect to y. So this will be e to the power ax plus by. Now if you differentiate this ax plus by with respect to y, so this gives you b, and we have the second function as it is. Now we have first function as it is, and when you differentiate this second function, so again this derivative of f is f prime ax minus by. Now when you differentiate this ax minus by with respect to y, so this is coming out as minus b. Okay, now from here if you have to find out a times del z over del y, so this will be a b. Why we are finding this a times del z over del y? Because in the problem we have to show that b times del z over del x, which we already find, and a times del z over del y is 2 times a b z. So we are finding this a times del z over del y. So this will be a b e to the power ax plus by f of ax minus by minus ab e to the power ax plus by f prime ax minus by. So let us mark this as equation 2 and this as equation 3. So adding 2 and 3, so what we obtain on the left hand side, we have b times del z over del x and plus a times del z over del y. Now when you put the value of the right hand side, so this will be a b e to the power ax plus by f of ax minus by plus ab e to the power ax plus by f prime of ax minus by. So this is the value of b times del z over del x plus now the value of a times del z over del y. So this will be a b e to the power ax plus by f of ax minus by minus ab e to the power ax plus by f prime ax minus by. So we can cancel these two terms because they are same with opposite sign. So we are having only 2 times ab, means this will be cancel out, and we are getting this 2 times ab e to the power ax plus by f of ax minus by. And what is this? This is our z. So this is coming out as 2 times abz. Okay, so this is how we can find out the b times del z, the value of b times del z over del x plus a times del z over del y. Now consider another example here. So now we are given a function. We are given a function z as log x cube plus y cube plus z cube minus 3xyz. and we need to show that, so this is an example here. So we need to show that del over del x plus del over del y plus del over del z whole square on sorry, this is not z, this is u. So when you apply this del over del x plus del over del y plus del over del z whole square on u, so this should be comes out as minus 9 over x plus y plus z whole square. Okay, so let us begin with the solution. So first we apply this del over del x plus del over del y plus del over del z on u. So this will be del u over del x plus del u over del y plus del u over del z. So we find these partial derivative, these three partial derivatives one by one. So first del u over del x, so that will be del over del x of, now the expression of u is log of x cube plus y cube plus z cube minus 3xyz. So when you differentiate, so first we have to perform this differentiation due to this log, okay, because log is here. So the derivative of log due to this log, we get this as 1 over x cube plus y cube plus z cube minus 3xyz multiplied by the derivative of, in fact the partial derivative of x cube plus y cube plus z cube minus 3xyz with respect to x. So this is 1 over x cube plus y cube plus z cube minus 3xyz, and this will be 3x square. The derivative of y cube is 0 because you are performing this differentiation with respect to x. Now again this derivative of z with respect to x is 0. Why? Because the difference between this question and the previous one, which we have already discussed, we are not considering this partial derivative of z with respect to x as 0 as we did here. You can see that we are mentioning this as del z over del x. You can check here. So we are not considering this 0. Why? Because here the difference between this problem is and the current one which we are doing is we are given here that z is the function of x and y, while in this problem z is simply a variable. Okay, so when you are performing this derivative of z cube with respect to x, so this is 0. Minus, now if you differentiate, so this 3 y z all are constant and the derivative of x with respect to x will be 1, so this is 3yz. So we are getting this as 3x square minus 3yz over x cube plus y cube plus z cube minus 3xyz. Now next we need to find out del u over del y. So this will be del over del y of, now we are putting the expression of u which is x cube plus y cube plus z cube minus 3xyz, and again we are using the same logic. First we have to differentiate this due to this log, so we are having 1 over x cube plus y cube plus z cube minus 3xyz, and the derivative of this expression with respect to y. Okay, so we are having this. So this simply, as we did in the previous part, that this will be 1 over x cube plus y cube plus z cube minus 3xyz, and the derivative of this expression with respect to y will be 3y square minus 3xz. So you can write this as 3y square minus 3xz over x cube plus y cube plus z cube minus 3xyz. And lastly we will find out del u over del z. So this will be del over del z. Now we are putting again the expression of u, which is log of x cube y cube plus z cube minus 3xyz. So this is again 1 over x cube plus y cube plus z cube minus 3xyz, and the partial derivative of this expression with respect to z. Okay, so now, so this gives us, again if you are differentiating partially with respect to z, so the derivative of x cube is 0, y cube is 0, and here we are getting 3z square. So this is 3z square minus 3xy, because this 3xy is constant and the derivative of z is 1, upon x cube plus y cube plus z cube minus 3xyz. So let's mark this as C, this as B, and del z over del x as A. So while we add A, B and C, so we get del u over del x plus del u over del y plus del u over del z. So this will be 3x square minus 3yz over x cube plus y cube plus z cube minus 3xyz plus 3y square minus 3xz over x cube plus y cube plus z cube minus 3xyz, and in the last term we are having 3z square minus 3xy over x cube y cube plus z cube minus 3xyz. So while we take the LCM, so this will be 3x square plus 3y square plus 3z square minus 3yz minus 3xz minus 3xy upon x cube plus y cube plus z cube minus 3xyz. So now here what we will do, we apply the formula of a cube. We will apply the formula of a cube plus b cube plus c cube minus 3abc. So this will be a square plus b square plus c square minus ab minus bc minus ca. So we use this formula here. Okay, so what we obtain, so and we take this 3 as common, so this will be 3 times x cube plus here we are also having this formula is, this should be multiplied by a plus b plus c. Okay, so we are having this, so this is 3 times x cube plus y cube plus z cube minus yz minus xz minus xy, and when we apply this formula here, so we have x plus y plus z, and we are having this as x cube plus y cube plus z cube minus xy minus yz minus zx. One more correction here, this will be not square, these are cubes. Okay, so these are cubes. So this will be, this brackets will be cancel out, and we left with only 3 times x plus y plus z. Okay, so this is the value of del u over del x plus del u over del y plus del u over del z. Now in order to calculate del over del x plus del over del y plus del over del z whole square on u, so this will be del over del x plus del over, means we have to apply this 2 times. Okay, so del over del z on del u over del x plus del u over del y plus del u over del z. Okay, means this simply means that you need to apply this 2 times. Okay, like this. So we have to apply this like this on u. So from here you will obtain like this. So we have already calculated this part. So from here you will get del over del x plus del over del y plus del over del z. Now the value of del u over del x plus del u over del y plus del u over del z is 3 times x plus y plus z. So this will be del over del x on 3 over x plus y plus z plus del over del y of 3 over x plus y plus z plus del over del z of 3 over x plus y plus z. So from here, now if you differentiate x 1 over x plus y plus z, so this simply comes out as minus times 3 over x plus y plus z whole square minus the derivative of 1 over x plus y plus z is x plus y plus z whole square minus 3 over x plus y plus z whole square. So combining all these terms, we are getting minus 9 over x plus y plus z whole square. So this is the value of our del u over del x plus del u over del y, or del over del x plus, so this is the value of del over del x plus del over del y plus del over del z whole square on u. So this is how do we apply the concept of partial differentiation. So that's all in this video, and we will take some more concept on partial differentiation, some more problems in the next video.